Hi there, this is Don McClatchie with Computer Modeling Group, and this next session is going to delve into the massive enablement that reservoir engineers are achieving using a cloud compute environment. So the modern drivers for reservoir simulation really center around two main things. You're trying to maximize your production and recovery factor, your employee efficiency, your resource utilization, really your revenue and profit. At the same time, you're trying to minimize risk around uncertainties in geology, operational considerations, economic environments, and price volatility. Really, it's about maximizing your return on investment. So for an engineer to optimize means doing more with less. Over the short term, you're optimizing individual wells, the well design, the completion design, the frac design. Over the medium term, you're trying to optimize the way you're operating your fields, looking at pressure distribution, looking at water injection or polymer injection, looking at steam distribution, these types of things on a field-wide basis. And over the long term, you're trying to optimize the entire asset portfolio, determining which assets to keep and develop, which ones to hang on to, and which ones to divest yourselves of. But traditionally, there's been some challenges in handling the amount of simulation work needed to do all of these different tasks. Highly variable workloads mean one day an engineer might do 2 or 3 simulations, and the next day he or she might do 200 or 300. Model level of detail ranges from small 2D models to massive full field several hundred grid block models, with a range of complexity depending on the type of process or in fact EOR process that's being investigated. So clearly there's a need for simulation, but with limited hardware and software in a traditional office, it's been a challenge. Now that we have the cloud compute environment, though, this has changed. There's no more queuing up jobs one after the other, waiting for them to be done. You can run them all at the same time. The system's instantly scalable and flexible, and thanks to the resources available from the major cloud providers, there's massive multi-core capability, thousands of compute cores at your fingertips instantaneously. And each one of the compute nodes are optimized specifically for reservoir simulation. And you can see an example in this plot on the right. As the number of cores are increased tackling a job, the speed to get the job done increases significantly, and the actual cost per job comes down using more hardware. So here's some other good examples. Traditionally, many models were run on single 4 or 8 core desktop computers or maybe a shared compute cluster. Now that we're in a cloud environment, your resources start at 8 cores, up to 32 on a single node, and if you get into a multi-node environment, you're looking at as high as 2,000 cores tackling a single model. Speed up's not linear, but as you can see, the results are drastic. This first example here, 55 well pairs of 6 million grid blocks. On a 36 core machine, it was 61 hours. In the cloud with 500 plus cores, you're talking 13.5 hours. 100 million grid blocks in this third example, goes from 463 hours on a single machine, move it into the cloud with 1,000 cores, and you're down to 170 hours. It's a significant improvement for the engineer. And when we talk about these optimization workflows, we're talking about optimizing things like net present value, well spacing, geologic realizations, history matching, frac sizing, all these different things. They can be optimized if you run enough iterations to come to the ideal solution. And you can see here in this plot where each dot represents one simulation job run, there's a normal workload that consists of anywhere from 5 to 50 jobs a day, but there's also optimization projects which can be 500 or 1,000 jobs in a day. And this is what cloud compute allows you to do in a very short time frame. So whether you're doing optimization of an unconventional resource, looking at fracs, well spacing, types of EOR processes, or you're involved in heavy oil, SAGD, trying to optimize steam injection. You can see in this example, after several hundred iterations of running a model, they're able to reduce steam oil ratio by 24%, oil production's up by 42%, or even just optimizing your completion based on local geology. Cloud compute is an enabler. Operational decisions can be made on a shorter time frame. Cost reduction is greatly enhanced and uncertainty is greatly reduced. So this has been a massive enablement for reservoir engineers. Thank you.